Dear students, I am Dr. Rajiv Sapre and this is 97th audio for you. In previous audio, we discussed about standard equation of the parabola, standard parabola in short. Now we will see this is not the only parabola. If it is the only parabola, it will be called as a parabola only. Why we are calling standard parabola? In case of circle also, standard equation, center is at origin, radius is a. But any circle, it is not necessary that center of that circle is origin. But when center is origin, it is called standard equation of the circle. Similarly, this was standard parabola. But there are other parabolas also. The parabola y square is equal to 4ax, where a is greater than 0, is symmetrical about x-axis. Its vertex is at origin and it opens out on the right side of the y-axis. Now consider the parabola whose equation is y square is equal to minus 4ax. A is greater than 0. Its vertex is also at origin, but its focus will be minus a comma 0. And its directrix is the line x minus a is equal to 0. The x-axis is the axis and it opens out to the left of y-axis. So y square is equal to 4ax is the parabola which opens to the right of y-axis, and y square is equal to minus 4ax is the parabola which opens to left of y-axis. The focus of y square is equal to 4ax is on the positive side of x-axis, and focus of this parabola y square is equal to minus 4ax is on the negative side of x-axis. The directrix of y square is equal to 4ax is to the left of y-axis, and directrix of y square is equal to minus 4ax is to the right of y-axis. You should draw these figures. At least refer the book. There also they have drawn these figures. Okay. You should understand that there are many limitations whenever such audios are created. It's not a video lecture where I can show everything. So as a supporting, you should be referring books. You should sit with pen and paper. This is many times I am iterating. If you want to learn sincerely from help of these audios, all such things are unavoidable. Now consider the parabola x square is equal to 4by. See, now instead of y square, we are saying x square is equal to 4by. Right? Now b is greater than 0. This is the parabola opening upwards above x-axis. Okay. Its focus will be on y-axis. Its directrix will be parallel to x-axis and below x-axis. So whenever it is x square is equal to 4by, its focus is 0 comma b. See, 0 comma b, and b is greater than 0. So it is above, means in upper part of y-axis. And its directrix is y plus b is equal to 0. Then consider the parabola x square is equal to minus 4by, where b is greater than 0. Then it is opening downwards. Okay, and its focus will be below on the means downside of y-axis. Focus will be 0 comma minus b, and its directrix is above x-axis and parallel to x-axis. Its equation will be naturally y is equal to b. That means y minus b is 0. So these are the four parabolas. Standard parabola is y square is equal to 4ax. Another parabola is y square is equal to minus 4ax. Both these parabolas have their axis as x-axis. Axis of symmetry is x-axis. Then you have two other parabolas, x square is equal to 4by, which is opening upwards, and x square is equal to minus 4by, which is opening downwards. Both these parabolas has their axis as y-axis. Axis is y-axis, like that. And their foci will be on y-axis, right? Their directrices will be parallel to x-axis. So in short, we can prepare a table about every parabola. We should know what is its focus, what is its directrix, what is the axis of the parabola, what is vertex of the parabola, what is length of the latus rectum of that parabola, what are the end points of the latus rectum, and where that parabola opens out. These are actually 7 properties that we should know about each and every parabola. Then your problem solving will become easier. So in a capsule form, I will tell you all this. Consider the parabola y square is equal to 4ax. Then its focus is a comma 0. Equation of the directrix is x plus a is equal to 0. Axis is x-axis. Vertex is at origin. Length of the latus rectum is 4a. End points of the latus rectum will have coordinates a comma 2a and a comma minus 2a, and this parabola opens to the right of y-axis. I hope you understood. We should note down all these things. We should prepare a table. This is a very good habit. Whenever many things are there, try to properly sort out those things, write them in a tabular form. It will help you. Data representation should be in such a way that immediately you should grasp the ideas. Now we will talk about other parabola. Y square is equal to minus 4ax. Focus is minus a comma 0. Directrix is x minus a is equal to 0. Axis again x-axis. Vertex origin. Length of the latus rectum 4a. End points of the latus rectum are minus a comma 2a and minus a comma minus 2a. And this parabola opens to left of the y-axis. This parabola opens to left of y-axis. Okay. Now next thing is the parabola x square is equal to 4by. X square is equal to 4by. Here the focus is 0 comma b. Directrix is y plus b is 0. Axis of the parabola is y-axis. Vertex of the parabola origin. Length of the latus rectum 4b. Ends of the latus rectum will be 2b comma b and minus 2b comma b, and it opens out above the x-axis. And finally the parabola x square is equal to minus 4by. Here focus is 0 comma minus b. Directrix is y minus b is 0. Axis of the parabola is y-axis. Vertex is again origin. Length of the latus rectum again 4b. Ends of the latus rectum will be 2b comma minus b and minus 2b comma minus b, and this parabola opens below the x-axis. So this is in a capsule form 7 properties about the parabola. Whenever you are told the equation of the parabola and you are asked to find what is the length of the parabola, length of the latus rectum, what is focus, what is directrix, axis, what is axis of symmetry, you can use this tabular data for solving any problem. Only thing is you have to just compare the equation with one of these 4. If it is y square is equal to minus 16x, you will use formula for y square is equal to minus 4ax. If it is x square is equal to 16y, compare it with x square is equal to 4by, like that. Okay, so that is why before going to solve the problem anywhere in mathematical theory, you should work first on the theory. Very, very important concept I am telling. Theory should be very strongly done, properly done. All the ideas that are there in the theory, you must know everything of those ideas, and then you can sit down to solve the problems. Without knowing proper theory, without having grip on the theory, you cannot solve problems from that topic. After I have told in one of the audios that you should work on all these things. Also see the solved problems in the textbook or whatever book you have. Solved problems from that book, you must go through them. Try to understand everything written in those problems, and then one fine day you also will be able to solve the problems. This is for sure. Now coming to all this table we have done now. Coming to parametric equations of the parabola. Okay, this equation that we are talking about, y square is equal to 4ax. This is called what? Cartesian equation of the parabola. Now if we take x is equal to at square, a into t square, and y is equal to 2a into t. Then you can easily see that what is y square? We are taking y is 2at. So what is y square? 4a square t square. Okay, and what is 4ax? X we are taking at square. So it will be 4a into at square. So it is also 4a square t square. So we have y square is equal to 4ax we get. By putting x is equal to at square, y is equal to 2a into t. So the point at a into t square comma 2a into t lies on the parabola y square is equal to 4ax. By different values of t, when you give, by giving different values of t, we get different points on the parabola. Okay, in other words, coordinates of any point on the parabola are expressed in terms of t. Coordinates of any point on the parabola are expressed in terms of t. Hence, t is called as the parameter of the equation. X is equal to at squared and y is equal to 2at. What is the parameter? T. And this x is equal to at square, y is equal to 2at. It's called parametric equation of the parabola. Okay, if t is parameter of the point P, we denote it as P in bracket T. And obviously the Cartesian coordinates corresponding to that value of t will be 8 into t square comma 2a into t. Okay, so this is the Cartesian equation and parametric equation. Y square is equal to 4ax is Cartesian equation. Whenever the equation involves variables x and y, it is Cartesian. But this type of equation where the dependent variable y and independent variable x is expressed in terms of t, and that values of x and y satisfies that Cartesian equation, then these two, x is equal to, here in case of parabola, a into t square, y is equal to 2a into t, they are called parametric equations of the parabola, as we have studied in circle. If it is x square plus y square is equal to a square, what were the parametric equations? X is equal to a cos theta, y is equal to a sin theta. So always whenever you are studying any curve, you will also like to study parametric equation of that curve. Okay. Now next thing is focal distance. The focal distance means what? It is a distance of the point P on the parabola from the focus of the parabola. So if P is that point and S is generally the focus that we take, so distance SP, segment SP first, it will be called as a focal radius, right? Segment SP is called focal radius, and distance of that, length of that focal radius is called focal distance. So what we will do, let P x1 comma y1 be the point on parabola, y square is equal to 4ax. If S is the focus and D is the directrix of the parabola, then you know the equation of directrix D is x plus a is 0. SP is the focal distance of the point P, and by definition of the parabola or by property focus directrix property, we know that SP and PM are same, where PM is what? Length of the perpendicular from P on the directrix. Okay, so PM will be x1 plus a. You can use perpendicular distance formula. So SP is also x1 plus a. So focal distance of the point P x1 comma y1 is x1 plus a. If P is at1 square comma 2at1, so in parametric form at1 square comma 2at1, then the focal distance will be x1 plus a. It means here it will be at1 a into t1 square plus a, right? So focal distance we have discussed. Remember, focal distance means distance of the point from the focus. Focal distance of the point we are talking about. If the point is x1 comma y1, then its focal distance from focus SA comma 0 will be mod of x1 plus a. Okay, if a chord of the parabola passes through its focus, then that chord will be called as a focal chord of the parabola. That chord will be called as a focal chord of the parabola. So these are certain properties, different parabolas and all those things we have discussed. We will solve some problems in the next audio probably. I hope you enjoyed this audio. Thank you.